What's going on YouTube? It's the Middle School Math Man. This video is going to be on solving systems of equations by using the elimination method. So basically what we're trying to do with the elimination method is we are going to try to eliminate one of the variables. Now, you're going to see what I mean in a second. But the first thing we need to make sure when we're solving these problems is that the variables are lined up. So what I mean by that is in this first problem, both the x's are lined up over here, the y's are lined up here, the constants are over to the right. If they were all mixed up, maybe this negative 3y was over on the right side of the first equation, you would have to get it to the left, so everything lines up. So, if we look at this first problem, we are going to try to eliminate either the x or the y. And how we're going to do that is we are going to either add or subtract the variables. So let's take a look. 2x and x, if I either add or subtract the x from 2x, they're not going to cancel. We're still going to have either 3x or 1x. But if we look at the y's, negative 3y plus 3y is 0. So if we add the second equation in the first one, we have negative 3y plus 3y, and those cancel. They eliminate. That's why it's called the elimination method. By adding those equations, by adding the y's, they have canceled. They've eliminated. So what's left is 2x plus x, that's positive x, so that's 3x, equals 14 plus negative 11 is positive 3. So again, those eliminated, and then what's left, we're just going to add, so 2x plus x is 3x, 14 plus negative 11 is 3. And now we're going to solve for x. So we get x equals 1. Now, just like with substitution, once we solved for one variable, we then took that variable and plugged it in for whatever variable it's solved for. So in this case, we know that x is equal to 1. So we're going to plug that 1 back into either one of these equations. It doesn't matter. However, I think the second equation is going to be a little bit easier because there's no coefficient with the x, so I'm going to do that one. So I'm just going to plug in 1 for x, because that's what we just solved. And then I'm just going to rewrite everything I have. So let's go ahead and solve that for y. So I'm going to subtract 1 from both sides. Those cancel. I'm left with 3y equals negative 12. And then to solve for y, divide both sides by 3. So y is going to equal negative 4. So your answer should be in an ordered pair. So your answer is 1, negative 4. If you were to graph these equations, they would intersect at that point. So there's one solution to this system. Let's look at the second problem. So here, if we look at these two equations, so we have matching coefficients with the x. We have 6x and 6x. So I think those are easily going to eliminate, but the way they currently are, this is positive 6x and positive 6x, the way they currently are, they are not going to eliminate because 6x plus 6x is 12x. So we need to make one of those equations negative, because if I multiply the whole bottom equation by negative 1, then I'm going to have negative 6x. So I'm going to put a subtraction sign here. So essentially what I'm doing is I'm multiplying the whole bottom equation by negative 1 to get 6x and negative 6x. Now when I do that, all of these signs are going to change. Because I can't just flip the sign of the 6x, I have to do it to everything else as well. So now I can eliminate. So those are eliminated. And what's left is 12y equals 24. 4 plus 20 is 24. So I'm going to finish this problem for y. So y is going to equal 2. Now once I have solved for one of the variables, I still need the other part of the ordered pair. I need the x in this case. So I'm going to plug the 2 in for y into either one of the equations. I don't think any of them is really easier than the other. I'm just going to choose the first one. So again, I plugged in 2 for y, and then I'm just going to go ahead and solve for x. So x is going to equal -1. So I want your answer to be written as an ordered pair. So again, this system has one solution, and the solution is -1, 2. That's where they would intersect. We are getting a little bit more challenging. The last one we will do will be the most challenging. So if we take a look at this problem, we are trying to figure out which one of the variables will be easier to eliminate. If we look at the y's, we have y and we have 3y. None of those are matching coefficients. The 2x and the 5x, 2 and 5 are not matching. This y has a coefficient of 1. 1 and 3 are not matching. So what we're going to need to do, I think it'd be easiest to eliminate the y. So in order to eliminate this y with positive 3y, I need the y in the top equation to be -3, because -3y plus 3y equals 0. So I just put parentheses around that, and I'm going to multiply the top equation. I'm going to multiply everything by -3. So when I do that, I'm going to rewrite it. I'm going to rewrite it below the first one, so that's -6x minus 3y equals +6. Now I'm just going to put a line through that one so I don't get confused. So now I have my two equations. So now if you see, I can now eliminate those 3y's. So 3y minus 3y is 0. That's what I'm trying to do. I'm trying to eliminate that. So then what's left is 5x minus 6x, which is -1x. -8 minus 6 is -2. So just go ahead and solve for x, and you should get x equals +2. One variable is solved. I still need the y. So I can plug it in for any one of these equations. I can plug it in for the original one I crossed out. I can plug it in for the second one. I can plug it into -6x minus 3y equals 6. It doesn't matter which one you plug into. So I'm going to actually do it back into my original equation. So let's see, I'm just going to erase that so I can see what it was. So it was 2x, but now we know x is equal to 2, so I'm going to substitute in 2 plus y equals -2, and now I'm just going to solve. So y is going to equal -6, so your final answer is 2, -6. So in this last problem, this problem is fairly challenging because we don't have matching coefficients. So 3x and 4x, the 3 and the 4 are different. When we look at the y's, 2 and -5 are different. So neither of those are matching already for us. So we're actually going to have to multiply both equations by something in order to get matching coefficients. So let's take a look at the y's. So we have 2y and -5y. So you need to think to yourself, what number does 2 and 5 go into? And you're probably thinking to yourself, 10. So we need to get those y's to be 10 and -10 so the y's can eliminate. So if we multiply the top equation by 5, we're going to get 10y. If we multiply the bottom equation by 2, we're going to get -10y. And then they'll be able to eliminate, which is what we are trying to do. So I'm going to rewrite these equations below. So 15x plus 10y equals -130. On the bottom equation, we have 8x minus 10y equals a negative 8. So all I did was I multiplied those equations, and I have to multiply everything by those numbers. I can't just pick and choose what I'm going to multiply by. I have to multiply everything. So now, as you can see, our y's are going to eliminate, which is our goal. So what's left is 23x equals negative 138. So we need to solve for x. So what's left is x equals negative 6. Again, once we have one variable solved, we just need to plug it back into any of the equations we have. I'm going to go ahead and plug it back into the first original equation we had. And then I'm just going to go ahead and solve for the other variable. So we're going to get y equals negative 4. So again, you just need to make sure you write it as an ordered pair. So negative 6, negative 4 is going to be your answer to that problem. So that one was difficult because we had to multiply both equations by a number in order to get matching coefficients. They weren't matching for us already.